We didn't come here to play.
King Kong.
Oh yeah.
Welcome to another video of Erudite Tutorials. Today we are going to learn about indices. To start with, let's look at the character of an index notation. When we have any character such as 2 squared, this tells us that 2 multiplies itself twice. If we have any character or any expression such as 4 raised to the power 3, it tells us that 4 should be multiplied by 4 3 times. So 2 times 2 would give us 4, that is 2 squared is equal to 4, and 4 raised to the power 3, 4 16, 16 times 4 is 64, so 4 cubed will give us 64. Now this is referred to as what we call the power. Okay, it can be referred to as power. Don't forget to continue this lesson with your note. This can be referred to as the power. It can also be referred to as the index or the exponent or the degree. Okay, and then what we have down here is what we refer to as the base. It's referred to as the base. So now we are going to look at some properties of an index notation. Now these are some rules that we follow when anytime we are doing indices. Now the x we see here, as said earlier, is referred to as the base, and then the a we see up here is referred to as the index. Okay, it could be referred to as index, it could also be referred to as exponent or power, or let's say degree. It could also be referred to as degree. So for these rules to work, the base we have here would have to be the same. Okay, that is, if you have 2 raised to the power 2 multiplied by 2 raised to the power 3, then this rule will work. So with this, what we do is we have 2 raised to the power 2 plus 3, and that will give us 2 raised to the power 5. Okay, so the base would have to be the same. The base would have to be the same. We have 2 here, 2 here, it will have to be the same. If you have something such as 3 squared multiplied by 4 squared, this will not work because the base are different. So with this, you have to expand this separately. That is 3 squared giving us 9, and then 4 squared giving us 16. Then you multiply 9 by 16. Okay, that would give us around 146. Okay, so 164. So we keep that in mind. If the base are different, it does not work. If the base are the same, it works. So once again, let's look at the rule. If we have any index where the base are the same, like x and x here, and they are multiplying, not adding, if they are multiplying, then what we can do is that we can add the powers. Let's move on. Now this is our second rule. Here it talks about division. In the multiplication, the base were the same, and then we added the powers. So in division, the base are also the same. What we do is that we subtract the powers. So for instance, if we should have any expression 2 raised to the power 5 divided by 2 raised to the power 2, or 2 squared, or 2 to the second degree, what we are going to do is we are going to subtract this 2 from this 5, and that will give us 2. That is one of the base, and then the power here would be 3. That is 5 minus 2 giving us 3. So that is how we deal with the second rule. And to help to keep in mind that we do not divide rules where divide terms where the bases are different. Okay, you cannot do this. Say you have 2 squared divided by 4 raised to the power 3. No, this doesn't work. Okay, the base would have to be the same. Always keep that in mind. And here we have the exponential rule. What it says is that if you have an index with an index, what you do is that you multiply the index or the powers. Okay, for instance, if I should have into bracket 2 squared then cube, what I would have to do is to multiply this index, that is the 2, by the 3 index, and that will give me 6. So 2 raised to the power 2 times what? 3, and that is what? 6. Okay, in case let's say I have 5 into bracket 5 squared into bracket 4, this is going to give me 5, then 2 times 4 would give 8. 2 times 4 would give 8. Okay, so we go by it that way. Now we also have what we call this is a property. Okay, these rules are what we refer to the properties of indices. Any number raised to the power 1 is equal to that number itself. So 7 raised to the power 1 equals 7. 2 raised to the power 1 equals 2. 1000 raised to the power 1 is still equal to what? 1000. So this should tell us that every number that exists on its own, okay, such as 1, 2, 3 till infinity, okay, they all have a power of 1. So ideally every whole number has a power of 1. Let's keep that in mind. Now this is the 5th rule, one of the easiest rule, which states that any number raised to the power 0 is equal to 1. So if I should have 7 raised to the power 0, it's 1. If I should have 10 raised to the power 0, it's 1. If I should have 0 raised to the power 0, it is still 1. Okay, don't be surprised about that. Okay, if you still have 0 raised to the power 0 is 1, because any number raised to the power 0 is 1. If I should have 5 raised to the power 0, it's 1. If I should have a million raised to the power 0, I'm still going to have 1. So any number raised to the power 0 is equal to 1. Then we have what we call the inverse property. The inverse property. With the inverse property, what we do is that we reciprocate. Where the power is negative, we reciprocate. Now keep in mind that every whole number on its own has a denominator of 1. Okay, but it is usually not written. Every whole number on its own has a denominator of 1. Okay, so if I should have 2, 2 has a denominator of 1. If I should have 6 on its own, 6 has a denominator of 1. So 1 as a denominator is not written in general. So with what we have here, anytime an index expression, okay, has a negative inverse, what we do is we reciprocate it. That is, the denominator we have here is flipped to the top, and then what we have here is flipped down here, but the negative sign is cancelled out and it becomes positive. So let's try this. Say we have 4 raised to the power negative 5. This would be equal to 1 over 4 index 5. As simple as that. You just have to reciprocate it. Now let's try this. What about 2? What about say 2 over 3? And 2 has a negative index of 4. We still have to reciprocate. So we are going to have 3 over 2 index 4. Okay, the negative is cancelled. Okay, the negative is cancelled. What about if we should have this, say 2 over 3 or 2, the negative inverse of 5. So we are still going to reciprocate, and this would give us say 3 over 2 index 5. But let's keep in mind that anytime we have a fraction in a bracket like this with an exponent of 5, this index here affects both the denominator at the same time the numerator. So this could be written as 3 index 5 all over 2 also index 5. So let's keep that in mind. So that is that. Watch out for some more exercises. Enjoy.